In the previous lecture, we learned about inverse function and the derivative of inverse function, inverse trigonometric functions, the rules of derivative of inverse trigonometric functions, rules of some inverse trigonometric function. Now we show some examples on the topic inverse functions or derivative of inverse functions or derivative of inverse trigonometric functions. There is question number first, using derivative prove that sin inverse x plus cos inverse x is equals to pi by 2. Here one equation is given and we have to prove left hand side is equals to right hand side. In this equation, cos inverse x plus sin inverse x plus cos inverse x is the left hand side of this equation and pi by 2 is another side, means right hand side of this equation. If we take left hand side, we can prove right hand side, or if we take right hand side, we can prove left hand side. In this proof, first we can write, given that sin inverse x plus cos inverse x is equals to pi by 2. It is a proof of this equation. We have to prove that sin inverse x plus cos inverse x pi by 2 is equals to pi by 2. It means that the value of sin inverse x plus a cos inverse x is pi by 2. First we take, let given function left hand side f of x is equals to sin inverse x plus cos inverse x. If we differentiate this function with respect to x, then the derivative of fx is f dash of x and the derivative of sin inverse is separate and the derivative of cos inverse is separate by using the rules of derivative of u plus v. The derivative of sin inverse x is 1 upon under root of x square minus 1 minus x square plus, again the derivative of cos inverse x is minus 1 upon under root of 1 minus x square. This plus and minus is cancelled, hence 1 upon under root of 1 minus x square plus minus 1 upon under root of 1 minus x square is equals to 0. Hence the value of f dash of x is 0. Therefore we can write f of x is a constant. Then we can write sin inverse x plus cos inverse x, x replaced by 0, sin inverse 0 plus cos inverse 0. The value of sin inverse 0, the angle which is sin 0, then we can write the sin 0 is 0, hence sin inverse 0 is also 0, plus the angle which is pi by 2, cos of pi by 2 is 0, hence we can write the value of cos inverse pi by 2, cos inverse 0 is pi by 2. After that, 0 plus pi by 2 is equals to pi by 2, therefore sin inverse x plus cos inverse x is equals to 0 plus pi by 2 is pi by 2, hence proved, which is a required proof of sin inverse x plus cos inverse x is equals to pi by 2. After that, the next question number 2 is differentiate the following function with respect to x, and the given function is sin inverse of x cube. First we consider this function y is equals to, let y is equals to sin inverse of x cube, and we have to find the derivative of this function. Then we differentiate with respect to x. The derivative of y is dy by dx, and we have to find the derivative of sin inverse of x cube. We know that the derivative of sin inverse x is equals to 1 upon under root of 1 minus x square. And again the derivative of sin inverse of fx is equals to 1 upon under root of 1 minus f of x whole bracket square into again a derivative of f of x. By applying this rule, we can write the derivative of sine inverse of x cube is 1 upon under root of 1 minus x cube whole bracket square into again the derivative of x cube. If you know the derivative of x raised to the power n is equals to n into x raised to the power n minus 1, then we can write the derivative of x cube is 3x square upon under root of 1 minus 3 into 2 x raised to the power 6, which is the required derivative of dy upon dx. Write down. Next one, second example, cos inverse of 2x square minus 1. First we consider given equation, let y is equals to cos inverse of 2x square minus 1. We have to differentiate the following function with respect to x. Hence we can write differentiate with respect to x and the derivative of y with respect to x dy by dx. Again we can the derivative with respect to x of the function cos inverse of 2x square minus x. We know that the derivative of cos inverse f of x is equals to minus 1 upon under root of 1 minus f of x whole bracket square into again the derivative of f of x. Hence we can write it, the derivative of cos inverse x is minus 1 upon under root of 1 minus 2x square minus x whole bracket square. And we take again a derivative of function, derivative of f of x means 2x square minus x is equals to minus 1 upon under root of, if we take x common on the square bracket, 1 minus we can write x square in bracket 2x minus 1. If we take the separate derivative of 2x square, then 2 is constant and the derivative of x square is 2x minus the derivative of x is 1. After that 2 into 2 4x minus 1 we can write minus of 4x minus 1 upon under root of 1 minus x square into 2x minus 1 or 1 minus 4x upon under root of 1 minus x square into 2x minus 1, which is the required derivative of y dy upon dx. The y is cos inverse of 2x square minus x. Write down. Next one, sin inverse of 2 raised to the power x. First we consider let y is equals to sin inverse of 2 raised to the power x. If we differentiate the given function with respect to x, then we can write the derivative of y is dy by dx. And again we have to find derivative of sin inverse of 2 raised to the power x. We know that derivative of sin x is equals to 1 upon under root of 1 minus x square. Again the derivative of sin inverse of f of x is equals to 1 upon under root of 1 minus f of x bracket square into again the derivative of fx. By applying this rule we can write the derivative of sin inverse of 2 raised to the power x is 1 upon under root of 1 minus 2 raised to the power x whole bracket square into again a derivative of 2 raised to the power x. We know that here the derivative of a to the power x is a to the power x into log a. By applying this rule we can write the derivative of 2 raised to the power x is 2 raised to the power x into log a upon under root of 1 minus 2 raised to the power x whole bracket square, which is required derivative of dy upon dx. You can write. Next example, which is example number 4, is cot inverse of 1 upon x square. If we differentiate the given function, first we consider the given function y is equals to cot inverse of 1 upon x square. If you have to find the derivative of this function easily, then first we convert this cot inverse of 1 upon x square is tan inverse of x square, because we know that cot inverse of 1 by x is equals to tan x or tan inverse x or tan inverse of 1 by x is cot x. After differentiate, now we take a derivative of y with respect to x is dy by dx, and the derivative of tan of x square is tan inverse of x square is 1 upon 1 plus x square whole bracket square, and we take the again derivative of x square. We know that the derivative of x square is 2x, hence we can write the derivative dy upon dx is equals to 1 into 2x is 2x upon 1 plus x raised to the power 4, which is the required derivative of dy by dx. Next one, example number 5 is cos inverse of under root of 1 plus x upon 2. First we consider given function y is equals to cos inverse of under root of 1 plus x upon 2. If we differentiate given function with respect to x, then we get the derivative of y is dy by dx, and the derivative of cos inverse of under root of 1 plus x upon 2 we can evaluate by using the rules of derivative of cos inverse of fx. We know that the derivative of cos inverse fx is minus 1 upon under root of 1 minus f of x whole bracket square into again a derivative of fx. Similarly, we can write it derivative of cos inverse is minus 1 upon under root of, here x is f of x is under root of 1 plus x upon 2, 1 minus under root of 1 plus x upon 2 whole bracket square, and we take again a derivative of considerable functions which is under root of 1 plus x upon 2. Minus 1 upon under root of 1 minus square and square root cancel 1 plus x upon 2, and we can write the derivative of under root of 1 plus x upon 2 is 1 upon 2 under root of 1 plus x upon 2, and again a derivative of 1 plus x upon 2. By using the chain rule we can apply here. Now we can write dy upon dx is equals to minus 1 into 1 upon, here we take a cross product of these two both function, 2 into 1 is under root of 2 minus 1 minus x upon 2 into 1 upon 2 under root of 1 plus x upon under root 2. Hence here we can write also it under root 2 upon under root 2 into, here 1 by 2 is constant and the derivative of 1 is 0 plus x 1. Here root 2 cancel. We can write this 1 upon 2 into under root of 2 minus 1 is 1 minus x into under root of 1 plus x. Both terms are in under root, then we can write it 1 upon 2 under root of, in first bracket 1 minus x and second bracket 1 plus x. If you know the rules of algebra, which is a minus b into a plus b is equals to a square minus b square, then we can write it 1 square minus x square, which is the required derivative of the given function dy upon dx. Here the minus sign is continue, minus 1 upon minus 1 means required answer dy upon dx is minus 1 upon 2 under root of 1 minus x square. Next one, example number 6 is sine square of sine inverse of x square. If we have to differentiate given function, first we consider y is equals to sine square of sine inverse of x square. After that, this function sine square of sine inverse of x square, we can write sine of sine inverse of x square whole bracket square. Now if we differentiate, here sine inverse and sine is cancelled, we can write it x square whole raised to the power 2. After that, we can write this term 2 into 2 x raised to the power 4. After differentiate with respect to x, we can write the derivative of dy by dx, which is taken as derivative of x raised to the power 4. By applying the rules of x raised to the power n, we can write the formula of x raised to the power 4 is 4 into x cube, which is the required derivative of y dy upon dx. Write down. Next question, question number 3 is differentiate the following with respect to x. Every example in this question is depend on rules of trigonometric function. For example, here cos inverse of 4 cos cube x minus 3 cos x. You know about rules of trigonometric function. If we differentiate the given function, first we consider given function y is equals to cos inverse of 4 cos cube x minus 3 cos x. If you have to solve this differentiation easily, then you know about the rules of trigonometric function, and we know the cos 3x is equals to 4 cos cube x minus 3 cos x. Here the given function is 4 cos cube x minus 3 cos x. If we replace the value of 4 cos cube x minus 3 cos x is cos 3x, then we can write it cos inverse of cos 3x. By rules of inverse trigonometric function, we know that cos inverse of cos theta is equals to theta. Hence we can write it cos inverse cos cancel. We can write the value of y is 3x. Now if we differentiate the given function with respect to x, then become derivative of y with respect to x is equals to derivative of 3x. Again 3 is constant function and the derivative of x is 1. We can write the derivative of y dy upon dx is 3, which is the required derivative of y dy upon dx. Example number 7 is cos inverse of sine of 4 raised to the power x. If we differentiate the given function, first we consider given function y is equals to cos inverse of sine of 4 raised to the power x. If you have to differentiate given function, then first we convert this function sine into cos. By using the quadrant rule, we can write it cos of pi by 2 minus x is equals to sin x. Hence, by applying this quadrant rule, we can write this function, which is sine of 4 raised to the power x is cos of pi by 2 minus 4 raised to the power x. Here cos inverse cos cancel, then we can write y is equals to pi by 2 minus 4 raised to the power x. If we differentiate given function with respect to x, then we can write the derivative of y is dy by dx. Derivative of pi by 2, which is constant function, is 0, minus, hence we take again derivative of only 4 raised to the power x. 0 minus of minus derivative of a to the power x is a to the power x into log a. By applying this rule, we can write the derivative of 4 raised to the power x. The derivative of 4 raised to the power x is 4 raised to the power x into log of 4, which is the required derivative of the given function dy upon dx. Next one, number 3 is sine inverse of under root of 1 minus cos x upon 2. First we consider given function y is equals to sine inverse of under root of 1 minus cos x upon 2. In the inverse trigonometric function, we convert whole terms into sine terms. But here, given that sine inverse of under root of, we know that 1 minus cos theta is equals to 2 sine square of theta. 2 theta is equals to 2 sine square of theta. Here, by using this rule, we can write 1 minus cos x is 2 sine square x by 2 upon 2. Here 2 is cancelled. We can write sine inverse of under root of sine square x by 2. Here square and square root is cancelled. Again we can write y is equals to sine inverse of sine of x by 2. If we cancel sine inverse and sine, then we can write y is equals to x by 2. Now we differentiate a given function with respect to x, then the derivative of y is dy by dx, and 1 by 2 is constant. We can write the derivative of only x, and the derivative of x is 1, hence we can write 1 by 2 into 1. Then the derivative of y dy upon dx is 1 by 2. Next one, example number 4 is tan inverse of 1 minus cos 3x upon sin 3x. First we consider that the function y is equals to tan inverse of 1 minus cos 3x upon sin 3x. If we have to find the derivative of this function, or if we have to differentiate given function, first we evaluate or first we simplify this trigonometric form into tan. Here tan inverse as it is, we know that 1 minus cos theta is equals to 2 sin square theta by 2. And we know that again the derivative sin 2 theta is equals to 2 sin theta into cos theta. From this we can write sin theta is equals to 2 sin of theta by 2 into cos of theta by 2. By using these two rules, we can write 1 minus cos 3x is 2 sin square 3x upon 2 upon, we can write the sin 3x is 2 sin of 3x upon 2 into cos of 3x upon 2. Here 2 is cancelled, sin square cancel, sin of 3x by 2, this whole term is cancelled, hence remaining terms are sin of 3x upon 2 upon cos of 3x upon 2. And we know that sin upon cos is tan, hence we can write this whole function tan inverse of tan of 3x upon 2. Here tan inverse tan cancel, hence we can write y is equals to 3x upon 2. After differentiating with respect to x, we get the derivative of dy upon dx is 3 by 2 is constant and the derivative of x is 1. Hence whole derivative of dy by dx is 3 upon 2. Here the next example number 5 is cot inverse of cos x upon 1 plus sin x. First we consider that y is equals to cot inverse of cos x upon 1 plus sin x. If we differentiate the given function, first we simplify this function and we convert into cot, or we can write this function also is tan inverse of interchange numerator and denominator 1 plus sin x upon cos x. If we take here function in terms of tan, then we convert 1 plus sin x upon cos x is tan inverse tan of any functions. We know that 1 plus sin x, this function 1 plus sin x, we have to convert. 1 means sin square x plus cos square x, and we can write this sin x is 2 sin of x by 2 into cos of x by 2. Hence we convert whole angles in x by 2. And also we can write sin inverse of x by 2 plus cos inverse of x by 2 also 1. Hence in the space of 1 we write sin inverse of x by 2 plus cos inverse of x by sin square x by 2 plus cos square x by 2. And sin x replace 2 sin of x by 2 into cos of x by 2. After that sin square x by 2 plus 2 sin of x by 2 into cos of x by 2 plus cos square x by 2, we can write it a plus b bracket square means sin of x by 2 plus cos of x by 2 whole bracket square. By applying the rules of a plus b whole bracket square is equals to a square plus twice ab plus b square, we can write also in form of sin of x by 2 plus 2 sin of x by 2 into cos of x by 2 plus cos square x by 2. Hence this term 1 plus sin x, we can write sin of x by 2 plus cos of x by 2 whole bracket square. Now upon cos of x, we know that cos 2x is equals to cos square x minus sin square x. Here the common angle is x by 2, hence we can write cos x is equals to cos square x by 2 minus sin square x by 2. We replace cos x by cos square x by 2 minus sin square x by 2. Here we write cos square x by 2 minus sin square x by 2. Now tan inverse of sin of x by 2 plus cos of x by 2 whole bracket square means sin of x by 2 plus cos of x by 2 into again sin of x by 2 plus cos of x by 2 upon here this form is a square minus b square, and we know that a square minus b square is a minus b in second bracket a plus b. Hence we can write this cos of x by 2 minus sin of x by 2 into cos of x by 2 plus sin of x by 2. These two terms, two brackets are equal, hence we can cancel it. Then we can write tan inverse of, first we write cos of x by 2 plus sin of x by 2 upon cos of x by 2 minus sin of x by 2. Here whole terms cos of x by 2 plus sin of x by 2 upon cos of x by 2 minus sin of x by 2 we want to convert in form of tan. First, if we divide cos of x by 2 both numerator and denominator, then we get tan inverse of cos of x by 2 upon cos of x by 2 is 1 plus sin of x by 2 upon cos of x by 2 is tan of x by 2 upon cos of x by 2 upon cos of x by 2 1 minus sin of x by 2 upon cos of x by 2 is 1 into tan of x by 2. We know that the value of 1 means the value of tan of pi by 4 is equals to 1. If we replace 1 into tan of pi by 4, then we can write tan of pi by 4 plus tan of x by 2 upon 1 minus 1 means again tan of pi by 4 into tan of x by 2. We know that tan of a plus b is equals to tan a plus tan b upon 1 minus tan a into tan b. Hence we can write tan inverse of tan of pi by 4 plus tan of x by 2 upon 1 minus tan of pi by 4 into tan of x by 2 is tan inverse of tan of pi by 4 plus x by 2. We cancel this tan inverse tan, then we can write pi by 4 plus x by 2. If we differentiate given function with respect to x, then we can write the derivative of y is dy upon dx. The derivative of pi by 4, which is constant function, is 0 plus here 1 by 2 is constant, and we can take a derivative of x. You know that the derivative of x is 1. Here 1 by 2 into 1, it means that the required derivative of y, which is dy by dx, is 1 by 2. Next example, next question, which is question number 4, is differentiate the following function with respect to x, and the given function is y is equals to sin inverse of 2 cos x plus 3 sin x upon under root of 13. If we have to differentiate given function with respect to x, then we first simplify whole terms into sin. First of all, we can write sin inverse of 2 cos x plus 3 sin x separate in two terms. 2 upon under root 13 into cos x plus 3 upon under root 13 into sin x. First we consider these two terms sin x and cos x. Let 2 upon under root 13 is equals to sin alpha, and 3 upon under root 13 is cos alpha. If you have to verify this term is exist or not, then it also can be written as, we know that sin square alpha plus cos square alpha is equals to 2 upon under root 13 whole bracket square plus 3 upon under root 13 whole bracket square is also 1. Hence, equation 1 become y is equals to sin inverse of 2 upon root 13 is sin alpha into cos x as it is, plus 3 upon root 13 is cos alpha into sin x as it is. We know that sin alpha into cos x plus cos x by sin x, by using the rules of sin of a plus b is equals to sin a cos b plus cos a sin b. By using this rule, sin a cos b plus cos a sin b is equals to sin of a plus b, we can write this whole terms sin inverse of into sin of alpha plus x. Sin inverse sin cancel. Here alpha plus x, y is equals to, we note that the value of alpha is sin inverse of, therefore sin inverse of 2 upon under root 13 is equals to also alpha. Or we can differentiate directly with respect to x. Here alpha is purely constant function, hence derivative of alpha is 0 and the derivative of x is 1. Hence we can write the derivative of whole terms dy upon dx is equals to 1. Write down. Next one, second example number second is cos inverse of 3 sin x square plus 4 cos x square upon 5. Similarly, we can differentiate this example again. First we separate whole terms 3 upon 5 sin of x square plus 4 upon 5 cos of x square. Here if we put 3 by 5 is equals to sin alpha and 4 by 5 is equals to cos alpha, then we can verify also it. We know that sin square alpha plus cos square alpha, sin square means 3 by 5 means 9 upon 25 plus cos square means 16 upon 25 is equals to also 1. Hence we can put 3 by 5 replaced by sin alpha and 4 by 5 replaced by cos alpha. Then equation 1 become y is equals to again cos inverse of, here 3 by 5 is sin alpha sin x square plus 4 by 5 means cos alpha cos of x square. We can write it again, first term cos alpha cos of x square or cos of x square minus into cos alpha plus sin of x square into sin alpha. After that, cos of x square cos alpha plus sin of x square into sin alpha is in the form of cos a cos b plus sin a sin b. And after that we can write this in form of cos of a plus b, because which is a required trigonometric formula. Cos of a plus b is equals to cos a cos b plus sin a sin b. Hence we can write this whole terms cos of x square a minus b, x square minus alpha. We can cancel it, cos inverse cos, hence we can write y is equals to x square minus alpha. If we differentiate the given function with respect to x, then we can write the derivative of y is dy by dx. Derivative of x square is 2x and the derivative of minus alpha, which is constant function, is 0. Hence, which is required derivative of y dy by dx is 2y upon 2x. Similarly, we can solve this example number 3. Y is equals to sin inverse of a cos x minus b sin x upon under of x square plus b square. First we simplify given bracket which is in separate form a upon under root of a square plus b square into cos x minus b upon under root of a square plus b square into sin x. Now we put first term a upon under root of a square plus b square is equals to sin x, sin alpha, and second terms b upon under root of a square plus b square is cos alpha. Also we know that sin square alpha plus cos square alpha is equals to 1. Hence we can calculate the value of a upon under root of a square plus b square whole bracket square plus b upon under root of a square plus b square is equals to also 1. Hence we can write equation 1 become y is equals to sin inverse of sin alpha cos x minus cos alpha sin x. By using the rules of cos of sin of a minus b is equals to sin a cos b minus cos a sin b, we can write it sin inverse of sin of a minus b means alpha minus x. Here sin inverse sin is cancelled, then we can write the value of y is equals to alpha minus x. Y is equals to alpha minus x. If we differentiate given function with respect to x, then the derivative of y is dy by dx. Here alpha is purely constant function, hence we can write the derivative of alpha is 0 and the derivative of x is minus 1. Hence dy upon dx is equals to minus 1, which is the required derivative of the given functions. Next question, question number 5 is differentiate the following with respect to x. Here example number first is tan inverse of 4x upon 1 plus 21 x square. First we consider the given function y is equals to tan inverse of 4x upon 1 plus 21 x square. Let us consider that y is equals to tan inverse of 4x upon 1 plus 21 x square. If you know about the rules of trigonometric function, which is tan inverse of a plus b upon 1 minus a into b is equals to tan inverse a plus tan inverse b, then we can solve this differential equation. And this differential form we can convert tan inverse of a plus b upon 1 minus a into b. If we factorize 4, then we can write 4x into 7x minus 3x upon 1 plus, we can write this 21 7x into also 3x. If we apply the rules of inverse trigonometric function, tan inverse of a minus b upon 1 minus a into b is equals to tan inverse of a minus tan inverse of b, then we can write this function as tan inverse of 7x minus tan inverse of 3x. If we differentiate the given function with respect to x, then we can write the derivative of y is dy by dx. Here we can take the derivative of tan inverse of 7x separately, minus again the derivative of tan inverse of 3x is again separate. We know that the derivative of tan inverse is 1 upon 1 plus 7x whole bracket square into again the derivative of 7x minus, and the derivative of tan inverse x is 1 upon 1 plus 3x whole bracket square into again a derivative of 3x. The derivative of 76 is 7 upon 1 plus 49x square minus 3x into 1 Derivative of 3x is 3. 3 into 1 is 3 upon 1 plus 9x square is dy upon dx, which is a required derivative of the given function y is dy upon dx. We can solve next example number second, tan inverse of 7x upon 1 minus 12x by using example number first. Similarly, we can find the derivative of tan inverse of 7x upon 1 minus 12x square. If we factorize 12 and 7 in terms of tan inverse of 4x, 7x is 4x plus 3x upon 1 minus 12 is 4x into 3x. Then we can write tan inverse of a plus b upon 1 minus a into b is tan inverse of 4x plus tan inverse of 3x. If we differentiate given function with respect to x, then we get the derivative of y is dy by dx. Here we can find the derivative of tan inverse 4x separate and the derivative of tan inverse 3x is again separate. Derivative of tan inverse x is 1 upon x, 1 plus x square. Hence we can write the derivative of tan inverse of 4x is 1 upon 1 plus 4x whole bracket square plus tan inverse of 3x is into again a derivative of 4x plus tan inverse of 3x is 1 upon 1 plus 3x whole bracket square into again a derivative of 3x. Derivative of 4x is 4. Hence we can write the derivative 4 upon 1 plus 4x whole bracket square plus derivative of 3x is 3. 3 into 1 is 3 upon 1 plus 3x whole bracket square, which is a required derivative of y dy upon dx. Example number 3, which is y is equals to cot inverse of b sin x minus a cos x upon a sin x plus b cos x. If we have to differentiate given function with respect to x, then we first convert this cot inverse into tan inverse. If we write this cot inverse in terms of tan inverse, then we interchange numerator and denominator. Numerator into denominator means a sin x plus b cos x upon in denominator b sin x minus a cos x. Now we have to apply here the rules of inverse function, which is tan inverse of a plus b upon 1 minus a into b is equals to tan inverse a separate plus tan inverse b separate. Hence we require this function in form of whole terms. Here this term is compulsory is 1. If we have to convert this term into 1, then we divide b sin x both numerator and denominator is equals to tan inverse of, we can write a sin x upon b sin x plus b cos x upon again b sin x upon denominator means b sin x upon b sin x minus a cos x upon b sin x. After that, here sin x is cancelled. We can write tan inverse of a upon b plus here b cancel, cos upon sin is cot x upon here b sin x cancel 1 minus a upon b into cos upon sin is cot x. We know that tan inverse of a plus b upon 1 minus ab is equals to tan inverse a plus tan inverse b. Hence we can apply this rule here. We can write separately tan inverse of a upon b plus tan inverse of cot x. Here tan inverse of a upon b is constant function. Again we can write it y is equals to tan inverse of a upon b as it is, plus if we have convert this part into tan, then we can write tan inverse of tan of pi by 2 minus x. Here tan inverse tan cancel, y is equals to tan inverse of a upon b plus pi by 2 minus x. Now if we differentiate given function with respect to x, then we can write the derivative of y is dy by dx. Derivative of tan inverse of AB, which is a constant function, then we can write the derivative of constant function is 0, pi by 2 again constant function is 0, this derivative is again 0, and the derivative of x, 0 plus 0 is 0, minus derivative of x is 1, hence we can write the derivative of y dy upon dx is minus 1. Write down.